Then myself, Lakshmi Prasanna, working as assistant professor in Department of Soil Science and Agricultural Chemistry, School of Agriculture, SR University, Warangal. As part of our soil science course, Fundamentals of Soil Science, today I'm going to discuss about the topic soil taxonomy. In the soil taxonomy, I'm going to give a in-depth description about the diagnostic horizons. So when we see the historical perspective of this, the formation of this of the soil taxonomy, the first documentation of soil taxonomy or the soil classification was over 4,000 years ago in the China. In between mid 1800s, so the soil classification was done, which is based on the soil suitability for various crops. In the 1800s, the system was developed in the Europe that considered the soil and its properties. The first US soil classification system was done by using the soil maps in the year 1899. It includes three categories. Like in the category 1, it deals with the soil provinces. In the soil provinces, it gives the broad physiographic regions. In the category 2, deals with the soil series. It describes about the kind of the parent rock, color, and the structure. In the category 3, it describes about the soil type, which includes the soil texture, which also includes the soil consistency. Dokuchu, who is known as the father of soil science, in the year 1860 developed the theory that is the soil. He defined the soil, that is, soil is a natural body which is affected by the parent material, climate, topography, vegetation, and time. Russians developed the soil system and published the classification system based on the differences in soil genesis in the late 1800s to the early 1900s. The Russian model classification system was described in the US in the early 1920s, but it was too large. That is why it has been ignored. US-based soil system scheme was presented by the scientist C.F. Marbut in the year 1927. Marbut translated the Russian system and credited most of his ideas presented in this system to the Russians. This scheme became this type of soil classification became more famous, and it was published in the year 1935. In 1935 US system includes 6 categories. In category 1, it deals with the soil type, which includes the surface horizons, texture, and the slope range. In category 2, it deals with the soil series. Category 3 deals with family groups. Category 4, grade soil groups. Category 5, inorganic colloids. Category 6, soil composition, which includes pedalfers and pedalocals. Marbut borrowed the concept of normal and abnormal soils from the Russian system of soil classification. It is related to the Davis description of hill slope development. Normal soils was in equilibrium with landscape downwasting. Marbut classification system only addressed about the normal soils. In 1938 US system, describes this type of soil classification describes with the pedalfers and pedalocals and had 3 classes in the category 6, which includes zonal soils, intrazonal soils, and azonal soils. Intrazonal soils are nothing but the soils which is formed with the influence of climate, vegetation, and landscape. Intrazonal soils are those soils which are formed with the properties, and it is the transition between the zonal soils and the azonal soils. Azonal soils are those soils which are formed in the absence of the factors, that is the climate, vegetation, and landscape. Some of the problems which are seen in this system includes vague definitions of soil, too much reliance on the virgin conditions, overemphasis on theories of genesis, too little emphasis on morphology, exclusion of soils that were not considered as normal. So these are the problems which are seen in the soil classification of in the year 1938. Soil taxonomy in the year 1935, it was made to totally redo the US system of soil classification. Series of 6 approximates between the 1952 to 1960. Seventh approximation was published for general testing. Additional revision was adopted in the year 1965. Soil taxonomy finally was published in the year 1975. Two orders, some of the revision has been done, like two orders have been added. Moisture regimes were included and redefined. Classification of most of the orders have been revised in this soil taxonomy, which was published in the year 1975. So soil taxonomy includes 6 category levels, which includes order, suborder, grade group, subgroup, family, and series. Soil's placement in particular taxon, placement of soil in particular taxon depends on the presence and absence of diagnostics, horizons, and features. Taxa are generally defined by the soil properties, and it can be interpreted in terms of expected behavior and response of soil to the use and the management. Nomenclature is the indicative of important properties of soil if a person is familiar with the classification system. So the nomenclature of soil, that is in the order, order generally ends with the name known as soil. So there are 12 types of soil orders, which I have discussed in one of my presentations. That is the soil order, which I have discussed in brief about each type of soil orders. So 12 types of soil orders, that is alfisol. So all which generally the order end with sol, that is alfisol, andisol, eridisol, entisol, gellisols, histosols, inceptisols, mollisols, oxysols, spodosols, altisols, and vertisols. So it includes suborder. Names of suborders have 2 syllables. First connotes something about the soil. The second is the formative element of the order. That is Udolph. It is an alfisol with woodic mustic moisture residue. So second is the first is the canotes, which deals description about the soil. Second is the formative element from the order which is taken. So Udolph is, so it is a type of alfisol which has an woodic soil moisture residue. Cement is an entisol with sandy particles sized throughout the together. Aqual, it is an altisol with an aqueous moisture residue. Grade groups describes about the prefix that suggests something about the diagnostic properties of soil. Here the suborder describes about the 2 syllables, whereas the grade groups describes about the diagnostic properties of soil. That is pale is nothing but the old, so it is deep withered soil. Plintha aqual, it is a wet altisol with plinthites. Udupi cement, it is a sandy entisol with an woodic moisture resin. Next is the subgroup. So subgroup deals with, so subgroup generally consists of the grade group which are modified with one or more objectives. So here is in the subgroup, typic is the central concept of the grade group. So the word typic is added for each subgroup. As like podic woody cement, it is an intergrade to the spodosol. Extra grade, it is a subgroups, and it is not integrating towards any kinds of soil. So let's see about the diagnostic horizons. So generally the horizon is nothing but the so horizons are generally developed from the soil profile. So soil profile is formed by the withering of rocks and minerals when there is proper development of soil, when there is proper development of soil caused by the various factors, parent material, relief time, and the biological activity, all these factors leads to the formation of soil, which takes some thousands of years to develop 1 inch layer of soil. So thereby the diagnostic horizons are created. So the master horizons describe the soil profile. Master horizons is nothing but the soil profile. So in soil profile, there are different types of horizons, like it is a horizontal layers of soil which are present in the soil profile. That is O horizon, A horizon, E horizon, B horizon, C horizon, and R horizon. O is the organic horizon, which is present on the topper layers of soil. A horizon is the top fertile layer. E horizon is the alluvial horizon. B horizon is the alluvial horizon. C horizon is the parent material, and R horizon is the bedrock, which is seen below level of the soil profile. Here, the master horizons describe the soil profile, whereas the diagnostic horizons are used for classification of soils. The master horizons are based on the appearance. So based on the appearance, the horizons are classified. As like if the soil color is deep black in color, then that particular soil is having the high amount of organic matter of the humus. Or if the soils is in red color, then there is more amount of accumulation of iron, aluminium in that particular layer. This is why the master horizons are based on the appearance, whereas the diagnostic horizons are formed based on the soil formation process. So there are two types of diagnostic horizons. Those are surface horizons and subsurface horizons. Surface horizons are known as the epi horizon. Epi is nothing but the above. Pedon is nothing but the cut of the soil. So epi is the surface horizon. Subsurface horizon is the endopedons. Endo means below. So those are known as the subsurface horizons. So in this PPT, I am going to give a detailed description about the surface horizon and subsurface horizon and its formation, and also the characteristics of formation. So there are 8 surface horizons and 18 subsurface horizons. So first we are going to see the epipedon, those are known as the surface horizon. So epipedon refers to the topmost soil surface layers. It differs from the master horizons, where it can be thinner than the A horizon. So generally the epipedons are nothing but the surface horizons, which refers to the topmost surface soil layers. So here the property of these particular surface horizons are mainly deal with the organic matter, presence of organic matter. So there are 8 epipedons, which includes maulic epipedon, umbric epipedon, cystic epipedon, polycystic epipedon, melanic epipedon, anthropoid, plagian, and ochric epipedon. So here the diagram describes here maulic epipedon, which includes the characteristics of this maulic epipedon is having the high base saturation. Umbric epipedon is having the low base saturation, whereas the ochric epipedon is low base saturation and is thick and light in color. Melanic epipedon is formed from the volcanic materials, whereas the cystic epipedon is a formation of the peat, muck, and the bog soil. So let's see the characteristics each one by one in the further slides. So first is the maulic epipedon. So maulic epipedon is one of the surface horizon having the high base saturation and the high fertility. High base saturation in the sense there are more amount of cations, that is the CEC of that particular layer of soil is higher. When CEC is higher, then obviously more amount of nutrients will be, the availability of nutrients is more where there is more base saturation. That is why these soils are most fertile in nature. These soils are identified by high levels of humus and organic matter present in them. It is because more amount of bivalent cations are present on the exchange complex. Bivalent cations like calcium, magnesium, potassium, sodium. So all these are the bivalent cations which are mostly present on this surface of these particular soils. When these cations are present, obviously there is a high base saturation. When there is high base saturation, then obviously the soils are most fertile and high fertility conditions because of the more presence of micronutrients and also the macronutrients. The other characteristics is the high base saturation, and the structure of this particular soil is weak to the strong in nature. It is considered as the most productive soils of the world. It is because it has high level of humus and cation exchange complex, and these are high fertile soils. Soils with modellic epipedon are formed under grasslands and savanna vegetation, but this type of modellic epipedon can also occur under the broadleaf forest vegetation and also under the coniferous forest. So here the important point as far as the JRF point of view is, here this surface is the dark layer, thick and the dark surface layer. So the surface layer is the thick and dark in nature because of the more amount of humus and high base saturation because of the more presence of the bivalent cations. Generally, these soils are most productive soils of the world. It is because of the high base saturation, and these soils are formed under the grassland and savanna vegetation. It may also occur under the broadleaf forest vegetation, like under also the coniferous forest. Next is the ombric epipedon. Ombric epipedon means thick, dark color and humus-rich surface horizon. It is thick, dark colored, humus-rich surface horizon. It cannot be distinguished from the mollic epipedon by eye. Here, the characteristics of mollic and ombric epipedons are is one or the same. The only difference is that the base saturation. So the characteristics of mollic epipedon, the characteristics of this mollic epipedon and ombric epipedon are one or the same, but only difference is that the base saturation. Here in mollic epipedon, the base saturation is greater than 50%, whereas in the ombric epipedon, the base saturation is less than 50%. So generally, these ombric epipedons are formed at higher elevations over acidic parent material. These are poorly drained and very poorly drained soils with low base saturation. These environments occur where there is slow rate of organic matter decomposition. So here the important point is that the characteristics of mollic epipedon and ombric epipedon is one or the same, and it cannot be distinguished by eye, but only difference is that in ombric epipedon less than 50% base saturation, in the mollic epipedon greater than 50% base saturation in all parts of the soil formation. Next is the melanic epipedon. Here the word itself says that melanin. Melanin is the color formation. It is the thick and dark colored formation horizon. Thick and dark colored horizon, that is known as the melanic epipedon. So this soil formation occurs generally from the volcanic ash parent material. Volcanic ash parent material is formed, that is why it is thick and dark colored in nature, having high amount of organic matter or the humus content. Secondary minerals like allophone. Allophone is one of the dominant mineral. So this dominant mineral, which is formed from the allophone is one of the clay mineral which is formed from the volcanic ash parent material, is one of the important characteristics of the melanic epipedon. So here the important point is that allophone is one of the clay mineral which is formed from the volcanic ash parent material, and this thick and dark colored horizon having the high amount of humus with low bulk density and high phosphorus adsorption capacity. Next is the anthropoic epipedon. Anthropoic epipedon is one of these surface horizons which is formed during long continued usage of soil by the humans. So these surface horizon which is formed by the continuous usage of soil by the humans. This continuous usage of soil by the humans can be done where the color and structure of the organic matter content is similar to the The color, structure, organic matter content of anthropoid epipedon is similar to the molic epipedon, and it is relatively having the high base saturation. All parts of anthropoid epipedon are dry, and they are dry for 9 months in normal years. The soils are not irrigated, and the dominant factor in the development of this anthropoid epipedon is the human activity. So the important point is that this surface epipedon is mainly formed by the long continuous usage of soil by the humans. So human activity is most dominant factor which is seen in the anthropoid epipedon. Anthropoid is nothing but the activities which are led by the humans. That is why anthropoid epipedon. So this anthropoid epipedon is the most dominant factor which is caused by the human activity or by the human cause. Next is the Plagian epipedon. Plagian epipedon is surface epipedon, that is the human-made surface epipedon. It is the human-made surface layer which is of 50 centimeters thick, which is produced by long continued manuring. The soil materials used for the bedding livestock, manure was spread over the fields for a long period of time for the cultivation purpose. The color of this particular horizon depends upon the organic matter used for the bedding material. So this particular epipedon is identified by the formation of artifacts, pade marks, and the map unit delineation, which is used to be straight, sided, and rectangular and higher elevations than the adjacent zone. So here the Plagian epipedon is nothing but the human-made surface layer, human-made epipedon, which is formed by the continuous long manuring, which is identified by the artifacts. Next is the histic epipedon. So the word histosols. So the word histosols. So histic epipedon comes from the histosols. Histic is nothing but the tissues or the organic matter. So here in the histic epipedon, the organic matter or the organic soil material is higher, or it is ranges from the thickness 20 to 60 centimeters in thickness. It is characterized by the saturation and reduction for some time in normal years, and it has been artificially drained. This histic epipedon normally occurs at soil surface, although it can be buried. This histic epipedon generally seems to be in black to dark brown color, and the density of this is very low in nature. Histic epipedon, so as the word histic means tissues or the organic matter, this epipedon contains more amount of organic matter. That is why this epipedon seems to be in dark brown to the black color. And there is formation of peat or the muck soils. So peat or the muck soils are those soils which are formed in the waterlogged conditions containing high amount of organic matter, where there is reduction of sulfates takes place, thereby forming the acid soil in these particular soils. So histic epipedon leads to the formation of acidic soils having high amount of iron, aluminum, and manganese contents in them. And it is formed near the waterlogged, swampy, or the dampy areas. Next is the folic epipedon. So folic epipedon, it contains the organic matter unless flowing with the soil. It is normally found on the soil surface, and it can also be seen when it is buried. So this folic epipedon is seen generally saturated with water for less than 30 days in normal years, hence they differ from the histic epipedons. Littering, decomposition, humidification, ripening, and mineralization are the governing process which are seen in the polycystic epipedon. So the difference between the histic and the polycystic epipedon is that histic epipedons are waterlogged conditions containing water over a long period of time, whereas the polycystic epipedon are also occur in the waterlogged areas with water containing less than 30 days in the normal years. So littering, decomposition, humidification mineralization or the process which are normally seen in the polycystic epipedons. So this is how the surface horizon seems to be the polycystic epipedon. Next is the ochric epipedon. So here the word ochric means light color. So as the surface horizon is in light color, it has low value chroma, but it is too thin to be molic and ambric epipedon. The ochric epipedon is too thin, dry, and too light in color. It contains little amount of organic matter. That is why it is too light in color, and it is hard when it is dry. It includes alluvial horizon at the soil surface. It is this type of ochric epipedon is generally developed in the forest vegetation. Next is the endopedons. So endopedons are nothing but the subsurface horizons. So the layers of soils that are located beneath the epipedons, the layers of soils which are located beneath the epipedon, and it is characterized by the specific properties such as texture, structure, and color, that is known as the endopedons. Unlike epipedons, endopedons are not defined by the presence of the organic matter. Diagnostic subsurface horizons can be characterized weakly developed horizons, as horizons feature by the accumulation of clay, organic matter, inorganic salts. Cemented horizons are the strong acidic horizons. So endopedons are nothing but the subsurface horizons which are present in the subsurface soil. So these are characterized by the specific properties like soil structure, texture, and soil color. Unlike the epipedons, the endopedons are not designated by the presence of the organic matter, but it includes the features like accumulation of clay, organic matter, inorganic salts, cemented horizons, and strong acidic conditions. Diagnostic subsurface horizons are weakly developed horizons which are formed by the accumulation of clay, organic matter, inorganic salts. Cemented horizons are the strong acidic horizons. So there are 80 endopedons, which includes albic, andic, angelic endopedons, agric endopedons, calcic and petrocalcic, gypsic and petrogypsic, cambic endopedon, duripan endopedon, fragipan endopedon, candic endopedon, natric endopedon, oxic endopedon, classic, sporic, salic endopedon, sombric, sulfuric endopedon, and glossic endopedon. So these are the 18 endopedons and 8 epipedons. So let's see one by one in detail. First is the agric epipedon. So agric endopedon. So the agric endopedon is found on the soils under the cultivation. This agric horizon is formed by the alluvial horizon that has been formed under cultivation and contains significant amount of alluvial sand, silt, and clay and humus. It is generally formed after the prolonged years of cultivation. Agric endopedon, it is formed under the soils of the cultivation. It is generally characterized by the alluvial horizons containing sand, silt, and clay and humus. It is generally formed for the prolonged years of cultivation. Next is the albic. Here the agric, the word means that here it is this endopedon is formed under the surface on the soils of cultivation over the prolonged years. Next is the albic horizon. So the word albus means white color materials. White color materials are which are present in the soils. So these are largely determined by the color of the primary sand silt particles rather than by the coatings of the color. The albic horizon generally occurs between the A horizon. It is an alluvial horizon with 1 centimeter more thickness. Here the important point is that the albic horizons are generally the white color materials which are formed on the surface, subsurface layers. Next is the anhydric horizon. Anhydric horizon is accumulated in the horizon. So this horizon is typically formed on the subsurface horizon. Next is the argillic horizon. Argillic horizon is normally a subsurface horizon with clay elevation. So the word argillic means clay elevation. Elevation means incoming. So the incoming of soil particles known as the elevation. So elevation, that is the B horizon which is seen in the soil profile. In the B horizon of soil profile, this elevation phenomena takes place. So that is the incoming of clay particles. All the clay particles will be settled in the B horizon, that is known as the clay elevation, which is seen in the argillic horizon. It has high amount of phyllosilicate clay. It shows the evidence of clay elevation, which is the major characteristics of the argillic horizon. This horizon is formed by the moving of clay from one horizon to the other horizon within that particular master horizons. The horizon development occurs in areas where there is high rainfall for effective leaching. So as I have said before, the word argillic is nothing but the clay, elevation of clay. Elevation of clay is nothing but the movement of clay particles from upper layers to the below layers, that is known as the elevation of clay. So it occurs where there is high rainfall for effective leaching. Next is the word calcic horizon. So the word calcic in the sense accumulation of calcium carbonate in that particular subsurface horizons. So this calcic horizon is an alluvial horizon having high amount of secondary calcium carbonate and other carbonates present in them. It has 15 centimeters or more thickness in nature. These horizons are generally present in the arid and semi-arid conditions, and this is very hard in nature by the formation of carbonates and bicarbonates of calcium. Cambic horizon, which is formed by the complex process of physical alteration and chemical transformation. This horizon is evidence of alteration, but it is weakly developed between the A and C horizons. Generally, the cambic horizon has less elevation evidence, which is found in the argillic and spodic horizons. Duripan is very hard subsurface horizon. Duripan is the subsurface horizon, which is very hard subsurface horizon. It is generally cemented by alluvial silica, supported by calcium carbonate. It is very firm, and even after prolonged wetting, which is known as a duripan. Fragipan is brittle in nature. Here, fragipan is an altered subsurface horizon with 15 centimeters or more thickness. It is brittle in nature and it has low amount of organic matter and high bulk density. Glossic subsurface horizon. It is generally formed by the degradation of argillic, tundic, and natric horizons, from which the clay and free iron oxides are removed. It generally consists of alluvial part and alluvial part, sometimes referred to as tonguing. Tonguing is one of the characteristic which is seen in the glossic horizon. Next is the gypsic horizon. Gypsic horizon is generally formed by the alluvial horizons with accumulation of large amount of secondary gypsum. So the word gypsic in the sense having high amount of gypsum contents in them. This gypsic horizon is generally formed in the arid environments which is rich in gypsum by formation of gypsic horizons. Here the accumulation of calcium sulfate, that is the gypsum, in 15 centimeters or more thickness, and 5% of more calcium sulfate is formed in this particular horizon. Condic horizon. Condic horizon is a subsurface horizon. It is a fine texture subsurface horizon. It is a fine textured subsurface horizon that has evidence of clay translocation and is mostly composed of low activity of clays with low CEC and low EC. Next is the natric epipedon. Natric epipedon is especially it is special kind with argillic horizons having high amount of sodium. Natrium means the high amount of sodium. It has the clay elevation which is generally found in areas having high amount of sodium percentage and sodium adsorption ratio that is greater than 13. Ornstein is a cementic horizon having the sporic material present in them. Petrocalcic horizon. Petrocalcic horizon is an alluvial horizon having high amount of calcium carbonates present which are cemented in this particular soil evolution. Petrogypsic horizon is the horizon which is formed with 10 centimeters or more thickness having the gypsum contents in them. Classic horizon, it is a horizon which is thick black to dark reddish in color with 2 to 10 mm in thickness. It is generally cemented with iron and manganese, oxides of iron and manganese and organic matter. Next is the salic horizon having more amounts of salts. It is having high amounts of salts that is known as the halite. Halite is nothing but the salt, that is the NaCl salt. It is more soluble salt accumulation, that is gypsum, that is 15 centimeters or more, having EC greater than 30 decisimon per meter. Podic horizon. Podic horizon is a subsurface horizon which is formed by the alluvial accumulation of sesquioxides and organic matter which is composed of sporic materials. This horizon is an alluvial layer with 85% of more sporic material. Here the main characteristics is that it is formed by the alluvial accumulation of sesquioxides of sporic materials. This type of horizon is generally seen in the pine forest. It contains the active amorphous materials composed of organic matter, aluminium, and iron. Next is the sombric horizon. Sombric horizon is the subsurface horizon which is seen in the mineral soils. It is formed under the free drainage which contains alluvial humus. Here the main characteristics is that strong leaching occurs in this horizon. When there is more leaching, particularly in the high rainfall areas, there is base saturation is very low in nature. All the cations will be removed along with the irrigation water or the rainwater. That is why there is low base saturation, which is seen in the sombric horizon. Next is the oxic horizon. So here the word itself says that contains more amount of oxides of iron and aluminium, having 1:1 type of clay, that is the kaolinite. So this horizon is a mineral subsurface horizon with 30 centimeters in thickness. It has low CEC and low content of witherable materials. And what is the dominant mineral seen in this oxic horizon? This horizon is generally formed at the advanced stage of withering. They represent the mature soils. These oxic horizons are dominated with the oxides and hydroxides of iron and aluminium. In this horizon, highly withered horizon which contains iron and aluminium with 1:1 type of clays and the resistant minerals such as quartz is the dominant mineral in this Arctic horizon. So here all the epipedons and endopedons are described in the main characteristics have been described in this table. So first in the epipedons, out of the 8 epipedons, that is the anthropoic, polystick, histic, melanic, molic, ocric, plagian, and ombric epipedon. So anthropoic epipedon is mainly formed by the human activity, high organic matter content, high phosphorus content. That is why it is dark black in color. Next is a polystick epipedon. Polystick epipedon is it is less saturated with water with less than 30 days interval per year, and it is the characteristics are one or the same with the histic epipedon. So in the histic epipedon, high amount of organic matter and amount of waterlogged condition throughout the year. In melanic epipedon, it is the word itself says that melanin content. It is thick black, very thick black in color, having high amount of organic carbon or the organic matter, which is commonly seen in the volcanic ash soils. Molic epipedon is relatively thick, dark, humus-rich, strong structure and high base saturation, that is greater than 50% base saturation. Next is the ocric epipedon. Ocric epipedon is the ocric means the color. This pale and too thin and pale and too light color is formed because of the little amount of organic matter. Next is the plagian epipedon. Plagian epipedon is the human-made horizon, which is formed by the continuous years of manuring. Ombric epipedon is same, the characteristics of ombric and molic epipedon are same, but there is low base saturation in the ombric epipedon. So in the anthropoic epipedon, the important factor is it is formed by the humans, and artifacts is the important characteristics of this anthropoic epipedon. Polystick epipedon, it is an organic matter horizon having the water less than 30 days in normal in a year. Histic epipedon having high amount of organic matter and waterlogged condition throughout the year. Melanic, it is thick black and dark black in color with high amount of organic matter, which is developed from the volcanic ash soils. That is known as the melanic epipedon. Molic epipedon and ombric epipedon. Molic epipedon is humus-rich and high base saturation, thick, dark, and humus-rich and having the high base saturation. Whereas in the ombric epipedon, it is also thick, dark, and humus-rich with low base saturation. Next is the ocric. Ocric is this horizon is very pale and very thin in nature because of the less amount of organic matter, and becomes very dry in nature, hard and dry when there is no water. Plagian epipedon is the human-made epipedon, which is formed by the continuous years of manuring. So these are the in brief and important points regarding the GRF regarding the epipedons. Next is the endopedons. At the subsurface horizons. So agric endopedon or the agric horizon, which is formed by the organic and clay accumulation. So formation of organic matter and clay accumulation just below the plough layer, which results in the cultivation, that is known as the agric horizon. Anhydric horizon having the high amount of calcium sulfate mineral with gypsum materials present in them. Albic, it is light colored structure with clay and oxides of iron and aluminium. Next is the argillic. Argillic is the clay elevation, silicate clay elevation takes place. Calcic is nothing but the accumulation of calcium carbonate and the magnesium carbonate in them. Next is the cambic. Cambic horizon is formed by the altered movement and also by the chemical reactions of the soil. In situ chemical reactions are the altered chemical reactions. Next to jury pan. Jury pan is a hot pan. Jury pan is nothing but the hot pan. It is hot because of it is strongly cemented by the silica. Silica. Next is a fragipan. Fragipan is a brittle pan which restricts the rooting. Next is a glossic horizon. It is the white alluvial horizon having the tongs in the BT horizon. Next is the gypsic endopedon. It has a high accumulation of gypsum. Next is the condic endopedon. It has a accumulation of low activity clays. Next is the natric endopedon, where there is high amount of sodium. Natric is nothing but the sodium, high amount of sodium, and there is the formation of the columnar or prism-like structure. Next is the orthostrine. It has the cemented podic materials. Next is the petrocalcic. It is a cemented calcic horizon. Petrogypsic is the cemented gypsic horizon. Classic is the thin pan with manganese and organic matter. Next is a salic endopedon, which includes accumulation of halides or salts. Sombric endopedon. Sombric endopedon accumulates organic matter accumulation. That is why dark colored and it is strongly leachable. Spodic epipedon. Spodic epipedon is the formation of spodic salts where there is aluminum oxides, iron oxides, and human deposition, low base saturation, forming the acidic parent material. So this is regarding the important points of epipedons and the endopedons. So there are 8 epipedons and 18 endopedons, and we have described the characteristics in brief in between the two tables. So we are seeing the other diagnostic soil features of these diagnostic horizons, which includes the abrupt textural changes. So abrupt textural changes occurs in the ochric and albic overlies the argillic considerable increase in clay for a short distance helps in the formation of the vertical distance of 75 centimeters. Next is the glacic formation. Glacic formation is nothing but the formation of ice or wedges. So it is also one of the diagnostic soil feature. Next is the lamellae. Lamellae is nothing but the number of clay enriched layers which are separated by the core textured layers in the alluvial horizons of 7.5 centimeters thickness of bands. It is seen, and it is the accumulation of clay bridges, sands, accumulation of clay bridging sand grains, lamellae occur in the vertical series. Next is the lithologic discontinuity. Lithologic discontinuity is nothing but it is formed by the change in parent material, which is the geological process rather than the pedogenic process, which are indicated by the abrupt textural change and particle size and stone particle size, abrupt textural change, particle size, and mineral composition of the rocks. Next is the slick and slides. Slick and slides is one of the diagnostic features seen in the black soils. So black soils, slick and slides is one of the diagnostic feature. Slick and slides is formed. So these are the polished, grooved clay surfaces produced on one soil mass by sliding over the other soil mass. So when so this slick and slides is mainly found where there is in the black soils. So in the black soils there is 2:1 type of clay minerals, expanding type of clay minerals. So during swelling and shrinkage phenomena, when the wetting and drying takes place, the two soil particles collide over each other. They slide over each other. Two soil particles they slide over each other. By sliding over each other, some friction or rubbing of the surfaces takes place in between these two soil particles. When the friction or rubbing of the soil particles takes place, thereby formation of the polished or the shining surfaces, white color shining is formed because of the friction or the rubbing surfaces occurs on the soil mass by the sliding effect, which is commonly seen in the black soils due to swelling and shrinkage property. Next is the plinthites. Plinthites is one of the diagnostic features seen in the optic horizon. That is, plinthites are nothing but the humus-rich humus poor. So they are poor in humus. They are rich in iron and poor in humus. Rich in iron, iron stone hardens irreversibly when it is being exposed to the repeated wetting and dry conditions in areas where there is soft red iron segregations, mottled appearance due to the oxidation. So due to the oxidation phenomena, the oxides of iron and aluminium, oxides of iron undergoes oxidation and irreversible wetting, it hardens. The ironstone hardens irreversibly after being exposed to the wetting and drying conditions due to the oxidation phenomena, which leads to the formation of plinthites or the brick formation, which is seen in the red soils where there is high weathering conditions. Next is the densic contact. So densic contact is a diagnostic feature seen between the soil and the underlying densic materials. Lithic contact is the boundary between the soil and the consolidated underlying materials. By digging with hand tools is impractical. Paralithic contact, it is a boundary between the soil and the weathered bedrock. So slick and slides are the polished groove materials when two soil mass slide over each other, which are formed by the swelling and shrinkage of clay. Plinthites are they are poor in humus and they are iron-rich compounds. They harden irreversibly after being exposed to the wetting and drying conditions because of the oxidation, thereby formation of bricks. Lithic contact, it is a boundary between the soil and consolidated underlying materials. Paralithic contact is a boundary between the soil and the underlying weathered bedrock, which can be done with the hand tools. Whereas lithic contact, it is the boundary between the soil and the underlying material, with which cannot be done with the hand tools. So here the other diagnostic feature includes abrupt textural change, glacic phenomena, which is seen in the ice and the wedges, lamellae. Next is the lithologic discontinuity, which is formed by the change in geological process rather than the pedogenic process, which is indicated by the abrupt textural changes and particle size. Slick and slides, plintite formation, densic contact, lithic contact, and the paralithic contact. So this is the information regarding the diagnostic horizons, that is the surface horizons, subsurface horizons, and the other characteristics of diagnostic horizons. So now we are going to see the important points regarding this. Important points regarding the JRF point of view. So Dokucho, who is known as the father of soil science, have presented the genetic system of soil classification. Dokucho is known as the father of modern soil pedology. So Marbet type of soil classification includes pedalfers and pedalocals. Pedalfers is the accumulation of iron and aluminium. So pedalfers is accumulation of iron and aluminium. Pedalocals is the accumulation of calcium carbonate. So these pedalfers and pedalocals is seen in the Marbet type of soil classification. Soil was characterized by the Joffe and Marbet based on the zonality concept. So Joffe and Marbet defined the soil based on the zonality concept. Seventh approximation in the year 1960 was followed and updated in the year 1975. So there are 8 Epipedons, but only 3 were discovered in India, and there are 19 Epipedons, but there were only 8 were detected in India. Among 19 endopedons, only 8 were detected in India. So Plagian epipedon is epipedon which is created by the humans. Central concept of the grade groups includes subgroup. So in the subgroup, the central concept of the grade group was determined. So there are 8 capability classification which we are going to see in the further PPTs of mine. So that is we deal about the land capability classification and land suitability classification. So epipedons definition is that diagnostic surface horizons are known as the epipedons. Diagnostic subsurface horizons are known as the endopedons. Higher category of soil taxonomy is the order, and lowest category of soil taxonomy is the series. Jelly salts is the recently formed soil order. So the soil order which is not found in India is the jelly salts. Antisols is the recently formed rhizome. Histosols is one of the soil order having high amount of organic matter. So it has high level of organic matter and permafrost condition is absent. Oxysols is one of the soil order with low fertility. The mollisols is one of the soil order having the high base saturation, or mollic epipedon or mollisols having the high base saturation. Inceptisols are the soil order where there is a beginning of the soil formation. So the soil formation from youngest to the oldest. So entisols followed by the inceptisols followed by the alphisols, and oxysols are the ultimately last withered soils. Klingeville and Montgomery provides the land capability classification. So in this PPT, we have discussed about the history of soil taxonomy and also the diagnostic horizons, that is the epipedons, endopedons, and other characteristics of diagnostic horizons, and some of the important points from the various chapters, which includes soil orders, soil taxonomy, diagnostic horizons, and types of soils in India. I hope this video is useful to everyone. If you like the video, please do like, comment, share, and subscribe my channel. Thank you.